Yeah, good evening. Very good evening. Okay, just wait here. Okay, so first of all, we are talking about the statistics, right? And wait, just a moment. We are talking about the statistics, and during the statistics, I told you that we are having two different categories of the statistics. Uh, Statistics. So the very first one is the descriptive statistics, and the other one is the inferential statistics. So we had already covered the descriptive statistics, and we are talking about the inferential statistics. So all these tests we can do during the inferential statistics, where we work on a lot of data, gather the evidences of the hypothesis testing, and then do a lot of tests on to the various data collected as the evidences. So few of the tests that I discussed. Now let's say here, I discussed about the t-test, or I can say the correlation test. So when I had talked about the t-test, so inside the t-test, we are having all the numerical values. Means during the t-test, we are having all the data which we are taking for the test. They are having the number data, integer data, I can say it here, in both of the columns during the t-test. So when we are just checking out whether the means are identical, so both of the data, either here or here, we do have both of the data in integer format. The same is happening into the correlation test also, that if we are having two variables such as height or weight, so there also, if I want to find out whether the two variables or whether the two columns are having the correlation with each other, so there also in my all the data, I am having both of the variable as the integer value. Now let's think out a situation where I'm having the data where my variables are categorical data. Suppose I'm having one of the variable one of the variable two. So these are two variables, means two columns I'm having, and here I'm having all the data in this format. So means both of the data, the point is both of the variables I'm having the character format. So if I want to find out whether the two variables or whether the two columns, they are dependent or independent, okay? So in such cases where I'm having the entire data based on the variable, means based on the character data, they are not integer data, they are character data. So, and if I want to find out whether the variables are dependent or independent, so in such cases we can do the chi-square test. So there is one of the tests here, chi-square test. Chi-square test is applicable to the place where my both of the variables are character data. So the point is here, like last time I did here, I'm having a variable one or variable two. And if both of the data I'm having, let's say, integral data, integer data. So in such type of data, I can find out the regression. Regression test we can do to find out the correlation between the two data, whether the two data are correlated or not to each other. But if I'm having two variables, variable one and variable two, as categorical data, so in such cases, I can have uh, chi-square test. I can use a chi-square test. Okay, chi-square test, we can use it wherever I'm having two variables as a categorical data. So let's say what is the data? Chi-square test basically. The chi-square test is a test of independence. Okay, it is a statistical test of independence to determine whether the two variables have significant relationships or not, and the two variables are categorical. Wait, today I'm having a little bit cold. Okay. Wait. Okay. So whether the two variables are dependent or not. So basically what happens whenever we do the chi-square test, so the default statement, a null hypothesis in case of chi-square test is, the default statement for the null hypothesis in case of chi-square test is, wait. So it's like suppose H0 is there. This is the null hypothesis. So the null hypothesis has, this is a null hypothesis. So the statement for the null hypothesis in case of chi-square test is the two variables are independent. Where the two variables are independent. And in case of alternative hypothesis is the two variables are dependent on each other. They are dependent on each other. Okay, so the two variables are independent in case of null hypothesis, and the two variables are dependent on each other. This happens when my two variables are my var1 and my var2. Two variables are categorical data. Both are categorical data. So whenever I'm having both of the data into the category formats, so there I can apply the chi-square test. Chi-square test I can apply there. So chi-square test is applied for the variables where the two variables are categorical data. And whenever I'm having two variables in numerical format, number data, so there I can apply regression test to find out the correlation into the data. Okay. So for this case here, let's see how to make a test of independence for the chi-square test here. Okay. So first of all, here, I'm taking one of the file here, role website.csv. Inside the role website.csv, I'm having two variables here. The two variables are basically, let's take the variable as the role website. Inside the role, I'm having two values. That one is student and teacher. Student and teacher. And in website, I'm having two values such as, let's take Facebook and LinkedIn. So suppose here I'm having role as a student and website as a Facebook. Role as a student means certain data I prepared Facebook, such as role as a teacher, and the website is LinkedIn. Role as a teacher and the website is LinkedIn. LinkedIn. Okay. Let's say here I'm having, okay, let's say I'm having student as the role, and somewhere in the website I'm having LinkedIn, or teacher as a role, and I'm having the website as a Facebook. So the point is that I'm having such type of categorical data. So here we can see this one is a role website.csv is created. And here, when I'm loading this file here, so we can see the values also which are coming here. As a role is one of the column website, and all the values which are here like teacher LinkedIn, student Facebook, teacher LinkedIn, student Facebook, or teacher Facebook. So in this way values are there. So the point is here, all the categorical data are there. The category data into the string format it is there. A nearby 33 means here 0 to 33, 34 rows are there total inside the role website.csv here. Okay, so here I just loaded the file. Now here, when I'm using this df.describe here, so inside it, here when I'm checking out the describe method, so here it is showing just like the role and the website. So inside the role here, total count is 34 rows. Unique values are like in role, I'm having teacher and student, and in website, LinkedIn and Facebook. Top one is suppose student, and the top one is LinkedIn here into the role and website. 21 times teacher appears, 18 times LinkedIn appear inside the particular data or this particular data. Okay. Information here it is just saying that you are having 34 rows into the role column, 34 rows into the website column as well. Categorical data are basically, I'm having all the values in category. I'm having all the values in string data. So inside the categories, just like I created a category as a teacher and a student as a category, or like here I'm having LinkedIn or Facebook as the category. So these are the categorical data. So suppose in role, only two categories can come, teacher or student, or in website, two categories can come such as LinkedIn or Facebook. So in this way, categories are present there. Categorical data are there. Okay, so categorical data means only two categories, three categories, or four categories are provided. And into that column, only out of those four values or out of two values, one value will be there. So all the data will be into the string format here. Okay, so the data type here it is showing. If I'm just checking out what are the data type here. So the data type is object. So when I'm talking about the object in role column or object in website column, object means string data. I'm having a string data. Now, what I did, I just took the entire data of data frame and I want to see this data into the table-like structure in the format of rows and column. Table-like structure into the format of rows-like column here. So here, I want to make a contingency table. Table means I need a rows, I need a column. So here inside the pandas, there is a cross table. So cross tab will allow us to make the cross table where easily I can identify the column and the rows as well. So here in first parameter, I'm writing df rule. So role here is coming. This one is a role coming here into the rows format. That roles are student and teacher. And the second in here, this column format, I need to describe the website. So website is given and website has Facebook and LinkedIn are there. Now here it is going to take the data for the role. And here it is going to take the data for website. Okay. Now, so here it is giving this data for the role and website, which is coming from the data set here. So here it is saying that there are 10 rows related with student and Facebook into the CSV file. 3 cases are related with student and LinkedIn. 6 cases are present, 6 rows are present with teacher and Facebook, and 15 cases are present with teacher and LinkedIn. So these data are provided there into the CSV file. So these cross-sectional data we needed actually. These are the actual data. And here it is saying, when I gave one of the parameter has the margins is equal to 2. So here true. So here it is going to build up these margins. So into the margins here it is saying that how many times student appeared with the Facebook and LinkedIn. So 10 plus 3, 13 times student appeared with the Facebook and LinkedIn. How many times teacher appeared? So 6 plus 15, 21 times teacher appeared into the CSV file. If I So this one is the rows details here it is giving, and here it is giving column wise detail, like Facebook appeared 10 plus 6, 16 times into the CSV file. LinkedIn word appeared 3 plus 15, 18 times. So basically here it is saying 34 rows are present overall. The point is here now I need this data, this cross-sectional data I need it, because these are the actual data. Now why we need it? Because when we see about the chi-square test say the chi-square test of independence is a statistical test to determine if there is a significant relationship between the two categorical variables. This was the formula. This was the formula for chi-square test. That one is sum of all the observed values minus expected value divided by expected value. So here making the square of it. So basically, let's see what are the observed and what are the expected values. So actually here I need these observed value. Well, I'll be telling you what are these observed and expected value. These observed value I need to put into the chi-square test. So this value I need it. So this value, observed value I need it. So from how I will be getting this observed value to put in the formula here, that I can get it from here. Here, this observed value. This is the observed value. This entire is a observed value. We call it observed value, which is going to be fit in this part, O minus E. E expected value will be automatically calculated. So I need this one. So basically here, after this, I need the observed value. I just given this point here. Just wait here. I just given this point here, this one. Now. Can you see here the name I provided df cross tab dot columns, df cross tab dot columns. Here the column names are Facebook, LinkedIn, and the row totals is the name I provided. And in index, df cross tab dot index, here I just provided the rows name as a student, teacher, and the column totals. So I need this data only. This data. Now, how I can fetch it out? Because if I need this data only, so I can just check it out, ilog function of pandas. So df dot ilog function I need it. So here I need to capture the rows as well as columns. So here 0, 1, 2, and here I need 0, 1, 2. Okay. 0, 1. So see here, 0 and 1. I need this Facebook and LinkedIn, this entire data. So into the rows also, I need these two, 0 and 1, and into the column also 0 and 1. So if I need these, so how can I write it? In rows 0 to 2, because 2 is exclusive, and in column 0 to 2. Okay, so 0 to 2, 0 to 2. So if I'm using this ILOC function, so here it is going to take rows 0 and 1. So 0 and 1 rows data will be captured, and here also 0 and 1. So 0 and 1. So this data will be captured. Okay, this data will be captured here. So when I did it, so I'm getting df cross tab dot ilog 0 to 2, 0 to 2 here. Okay, so I'm getting this data, 10, 3, 6, and 15. So this one is the observed value I needed. Okay, now what I'll do, because I need to find out the chi-square test. So for this, I'm having a predefined library. Entire predefined library I'm having for to find out this chi-square test. So here I can call this library. I just call this one import scipy.stat. Inside the scipy.stat, I'm having a chi-square test. So scipy.stats I'm going to call, and this value, which is this one, observed, you can see it here. I just give it as a name. This I need to capture. So this df cross tab dot ilog 0 to 2 and 0 to 2. So here it is going to give 0, 1 rows and 0, 1 column. 0, 1 rows and 0, 1 column here. That is written into the observed. Observed here. Okay. I will be taking this observed variable where the values are present here. And what I do, I will be using one of the functions in scipy.stats. Inside scipy.stats, inside scipy.stats, there's one of the function present with the name of chi2 contingency. So it means this one is a chi-square contingency. Okay. Chi-square contingency. This is a test provided under scipy.stats. So if I'm calling import scipy.stats as stats, so here I want to call stats chi-square contingency, and here I can give the value observed. So this observed value already I had captured above, variable I had captured. So I need to give here observed. Now, like if I talk about the formula, observed minus expected divided by expected, this one is the chi-square formula. So all the other values will be automatically calculated. Means here chi-square contingency from stats, scipy.stats, it will be needing only observed data. Rest of the expected value of the other formula, it is going to calculate itself. So here, in stats, I'm just calling here imports scipy.stats as stats and stats.chi-square contingency. And here I'm just giving observed value. So here I just taken a observed value. This is the observed value. This one is the observed value. So that I'm going to put it here. Here I'm putting it. So chi-square test automatically will calculate the other values. And what it will deliver me, it will be giving me back, it will be returning back me few values, such as just like chi-square value, some p value, certain more return points it is going to give to me. So I need to check it out, the p value. This p value I need to focus. Automatically it will be calculating the expected value also. Let me tell you, like here, if I check about, just wait. Like here, how basically here, this expected value is calculated, because if I'm saying O minus E upon E, so how this expected value is calculated for the chi-square test here, expected value, how manually it is going to calculate here. Here it is taking to calculate the formula such like row total into column total here. Row total, just wait, row total into column total divided by grand total. So here row total, if I'm taking, suppose this I'm taking it here. What is the row total? Row is this one. So row total is 13, 10 plus 3, 13. Multiply by column total. So 10 plus 6, 16. So row total into column total divided by 34 rows. Total number of rows are 34. So the expected value is calculated. Okay. So for individual points here, expected values are calculated basically. But here we are not going to calculate. Everything is calculated by the chi-square contingency automatically. And even we do not need it. We need to focus on p value here. So here I'm going to take this one. Observed here. Scipy.stats.chi-square contingency observed is equal to observed. So here all the values are there and it will return you chi-square p value. What I'll do here, a lot of values it is going to show me, but here I need to focus on the p value. So let me check it out, the p value. So p value is there. So let me check it out, the p value. This was the p value. What is the p value here? Okay, you can see the p value. It is there. So it means, see here, p value, it is saying 0.01. 0.016 means here 0.01. So null hypothesis, now let me create here null hypothesis in this case of chi-square test. Null hypothesis is two variables are independent of each other. This one is the null hypothesis statement. Alternative hypothesis is two variables are dependent. These are the default statements of chi-square test. So here I need to check it out. P is equal to 0.01. Now I need to check here that P value is greater than 0.05. Then your null hypothesis is accepted and alternative is rejected. But here P value is 0.01. So P value is 0.01. So it is less than 0.05. So the case is reverse here. So here null hypothesis is rejected, alternative is accepted. What does it conclude? Null hypothesis is rejected, alternative is accepted. That means the two variables, role and website columns, the two variables are dependent on each other. So here it is saying the two variables are dependent on each other. Okay, the two variables are dependent on each other. So the conclusion comes here, the two variables are dependent on each other. So in this way, it is going to calculate. Right? So basically P value is calculated internally. Here P value is calculated here internally. It is taking all the values and then it is calculating its P values here. Right? So in this way, we need to accept it. So basically, P value is a significance value. 0.05 is a significance value here. So even we can say here that we can call that 0.05 is a significance value. With it, P value is matched. Okay, P value is matched here. Just wait. Okay. So this is one of the tests like regression test or chi-square test. We can do it. Now, let's see, suppose I'm having 2 or more categories. Let's say, assume, suppose there is a particular grade, any grade you can take, any class or grade you can take. Suppose there's a undergraduate first year, UG first year. Grade is there. And one of the professor took a test of any particular subject. So let's say there are 3 sections, A, B, and C section. So the professor conducted the test in all these 3 sections. Now, suppose I say 50 students are in A grade, in B section 50 students, and C section also 50 students are there. So all the students gave the same examination. So now here the professor wants to understand that is there any variations in the marks of A, B, and C section, all the 3 sections, or is there any variation within the section? So if one wants to find out the variance or the variation of the marks within the section or among the section. So here means if one wants to understand that is there any variance is present inside the section for the marks. So student achieve a lot of different marks. So how much is the variations within the sections also for the marks? And how much is the variation among the section? That how much is the variation of marks coming in A and B section, in B and C section, in A and C section. So it means one wants to study about the how much the variance coming within the section and among the section for the marks. So that can be done with certain tests such as ANOVA test, analysis of variances test. So this is one of the tests. So basically, statisticians use ANOVA, ENCOVA, MENOVA, MENCOVA, MENCOCOVA, means there are so many tests are associated here. So, but here I'm taking a very simple test, ANOVA test. So here to do the ANOVA test, basically there is a big calculations going on. But here in scipy.stats, this particular library, I am having one of the tests, F1B. F1B is one of the tests, which is an ANOVA test through which we can find out the analysis of variance and find out that how much is the variance among the marks within the section or among the section. So here also we can find out the p-value, calculated p-value. So what I can do here, I can take the ANOVA test here. So basically, ANOVA test you can see here. By chance, ANOVA test is very large actually. There's so many calculations we have to do. But because we are having a library, so that's why we'll directly use the library, and library will do entire work for us. So here, analysis of variances here, ANOVA test is used to compare the means of more than 2 groups. Groups means differences in fact by analyzing the variances. So here we do have F1-way test for the analysis of variances. So the by default here, the ANOVA hypothesis is, for the null hypothesis, it says that all the group means are equal. If all the group means or average are equal, it says there is no variance into the data. There is no variations into the marks of different sections of a particular class. An alternative hypothesis says that there is some variations. There is means are different here. So here, if I'm using ANOVA test here, so here I will be using scipy.stats import F1 way. So simply I'm going to use from scipy.stat import F1 way. So here in F1 way, ANOVA tests are being done. Analysis of variances test will be done automatically. So what I'll do, simply I will be taking any marks, any 3 variation marks here I'm taking. So I created here marks for section A, marks for section B, and marks for section C. So I created 3 groups into the form of list. And now here I am passing all these 3 different marks in F1 way. So F1 way I had already taken from scipy.stat F1 way. So inside F1 way here, all 3 different section marks I had provided. F1 will do entire calculations to calculate the analysis of variances. So here I need to see the output, which is a p-value. So I need to focus on the p-value. What is the p-value coming here? So here 0.83. So here p-value is 0.83. So if 0.83 is coming into the p-value is this one. So p-value is greater than 0.05. So it means this is greater. So it means null hypothesis is accepted, alternative is rejected. So it means if null hypothesis is accepted in this case, it means it says that all the 3 section marks are equal, or the group means are equal. It means there is no variations into the marks. There is no variations into the marks here. So there is no variations into the marks. There is no variations into the marks here. So all the sections are having, all the students of different sections are having almost similar type of marks. So there is no much variation. So in this way, we need to check it out, the p-value. Else, if we start doing the same task with manual cases here, yeah, F1 way is one way ANOVA, right? Otherwise, if I started taking this manual process of ANOVA, so I need to make a lot of calculations here in Excel. A lot of formulas I need to apply it here in Excel. This was a manual process, but it's very complicated process. So here directly I will be using F1 way. So basically here, F1 way here, it means it will be showing here ANOVA test. After this ANOVA test, there are so many tests are there. Generally, statistician use those tests here, but this one is a general test I'm showing to you. Okay. So that is like overall for inferential statistics. That means I just took the very fundamental, very basic steps of the inferential statistics. Now let's go ahead with outliers. as you know now that basically what are outliers and how I can detect the outliers. So basically, I can use the visualization method of box plot where I can find out the outliers. This is one way. So now what I'm going to do, I'm going to take one of the file and try to find out whether in a particular file outliers are present there or not. So I will be using this data visualization method. And then I would like to clean the outliers. So here, let me take a one file randomly. So here I'm taking one of the file. Suppose here I just load a lot of libraries, pandas, numpy, matplotlib, a lot of library I loaded because I want to see that any particular file is having outliers or not. So how can I check that? Here I'm taking one of the file president_heights.csv. You can see this file president_heights.csv. Suppose you can inside this file basically there's a lot of you can see here there's a lot of nearby multiple president names are there and their correspondingly heights are there. Okay, I loaded this file and let me check it out, the outliers are there or not. df.column. So here it is saying inside this file the column names are order, name and height. Now I want to see that here inside this plt.boxplot here it is just showing you df.heights. Okay, so here it is showing you plt.boxplot df.height. Okay, so here what I'm taking students, this particular column name here I'm taking heights, I'm going to take it. So plt.boxplot df.height. So inside the height I want to check whether the outliers are there or not. So if I check this df.height, so here I'm not getting any outliers right now. The box plot is clean, so there is no outlier here. There's one more method. I can use quantile method of pandas also. Inside the quantile method of pandas, here also I can check it out whether there is an abrupt change into the value or not. So from there also I can detect the outliers presence or not. So if I check it out, suppose 0th percentile, the value, the height at the 0th percentile of any president is 163. At the 10th percentile, it is 170 is the value of the height at 10th percentile. At 30th percentile, 175 is the height. At 80th percentile here, 185 is the height. At 90th percentile, 188 is the president height. And at 100th percentile, 193 is the height. So basically, I can say that if I see these value, the changes coming into this value, so they are uniform. They are uniform changes. There is no abrupt changes. So I will say no outlier. There is no outlier. Everything is clean. Now what I do, I am taking any other file. So here I'm going to check multiple files to find out the outliers. So here I'm just checking it out, hr attrition rate.csv. These all files are basically in GitHub. Now here, there are different values. You see here, different columns names are there. So I can take any numerical column. So in df.column here, different columns are there. So I can pick up any numerical column and start checking it out whether the outliers are there or not here. Okay, so here, this is the part of statistics. We are covering the part of statistics, actually, outliers. Okay, now here you can see, I can take any column name such as satisfaction level. And here I can write plt.boxplot. Because with the help of boxplot, I can check out the outlier. So here I'm just taking satisfaction level, df1.satisfaction level. This I'm taking it here. Okay, let me check it out whether the outliers are there or not. Here, there's no outliers. It is clean. I can use the quantile method also. Just like here, I can say the quantile method. So you can see here, at 0th percentile, 0.09 value is there. At 30th percentile, 0.49 values is there. At 90th percentile, 9.92, and at the 100th percentile, 1 value is there. Basically, satisfaction level is there, and inside the satisfaction level column, there is nothing outlier. Now come to brain size. Suppose here brain size is there. There's one of the file I can take it, brain size. Inside this brain size, there are a lot of numerical columns such as FSIQ, VIQ, PIQ. Any of the column I can take it, just like I'm just taking out the column, any of the column I can take it, and I can take it out the outliers. So here I'm just taking out MRI count. Suppose MRI count is there, I'm going to check out the MRI count here. So here in MRI count, everything is clean, so no outlier. I can take FSIQ, VIQ, or PIQ, any of the column. FSIQ also in box plot here, everything is clean, so there is no outlier here. Okay. Titanic train.csv. Now, students, here I'm taking one of the file Titanic train.csv. Lot of numerical columns are there, so I can start checking it out. Suppose there is one of the column fair. I can take this column here, fair, plt.boxplot, tf.fair. So fair, I'm going to take it. tf.fair. See here, in fair, outliers are there. In this particular column, outliers are there. So it means this file carries the outliers. These are all outliers inside the box plot. Okay, so it is there. Now what I do, I'm taking one more file here. House price data median.csv. There are a lot of columns are there, numerical columns. I can take suppose lot area, total basement surface area, garage area, any of the column here I can take it and start looking out outliers are there or not. So here I'm taking one of the columns such as lot area. Lot area is there. Lot area. You can see here in lot area, outliers are there. These are outliers. If I'm checking out the quantile method, now see how to check out quantile. In 0th percentile, 1300 value is there inside the lot area. In 10th percentile, 5000 is the value. Okay. 5007,889. Just see here. Just see. 80th percentile, certain 12,000 values there. 90th percentile, 14,000 values there. And in this last 100 percentile, 2 lakh. So there is a wide gap between these two. Here, it is 14,000 and here it is 2 lakh. So jump is there. The value changes abruptly here, 14,000 to 2 lakh. So here now, there is one more thing, you know. You can see the jump here. See here. See the jump. Here the values are coming and see. Jumps are there. So these jumps says the outliers are there. Different values are there. So there should be no jump for no outliers. So here it is saying, yeah, in lot area, outliers are present. And let me check it out, another column, total basement surface area also. Here also it shows with a figure in box plot, outliers are present here. Okay. So this is outliers are present here. So here also, if I'm checking it out, box plot, here also it is just showing, yes, outliers are present. Changes are there, abrupt changes are there. So yeah, outliers are present. In total basement surface area also, if you check it out, the last one, 90th percentile and 100th percentile, 1600 value and 6000 values are there. So the changes are abrupt here. 1600 and 6100 means here 6000 and 1600. So values changes are there. Okay. In garage area also, you can see here in garage area also, yeah, outliers are present there. So overall, we can say, yeah, this file carries house price median.csv file has outliers there. You can see here in here also, in both of the ways I'm looking vertical or horizontal, yeah, outliers are there. See this value. Ninetieth percentile and last 100 percentile gaps are there. 57 and 14. Okay, so this is there. So changes are there. Now see here, I want to draw a scatter plot. Lot area and garage area. Here it is saying outliers are present here. So the point is here, inside this file, there are a lot of, inside this particular file, there is a lot of outliers. I can take any other column also, such as total rooms and lot area. Here also it is showing outliers are there. So the point is that it is proven that, yeah, this file holds a lot of outliers. Now, what I'll do here, I will be using a mathematical method through which I can just check it out the outliers. Okay. So here we are going to discover outliers with mathematical function. So with the mathematical function, there is one of the formula here, which is a z-score. Z-score, which says x minus mean divided by standard deviation. X minus mean divided by standard deviation. Here it says for the set. So x means every data points minus mean divided by standard deviation. So this is a basically mathematical formula. We can use it to find out outliers. So what I'll do, I will be calling the z-score now and giving the z-score the entire HF, the entire data frame where the values are holding. HF is a house data frame. Why? If you check it out, the name here, HF. Where house price data median.csv, you can see here again. HF, house price data median.csv, it is present here. Okay, and I'm going to take it down. HF, see here, HF. So here I'm going to use same HF, house price data median.csv. So here I'm going to take this one. So HF, as I told you, HF is a house price median.csv, data frame is there. I want to find out the Z-score of entire house data frame values, entire file. So here I'm just calling from scipy.stats import Z-score, and I'm just calculating the Z-score of the data frame where house price median .csv is present. Okay, this one is present. Now, what I do here, Z-score, now I'm using np.absolute. Why I'm calling it np.absolute, let's understand. This one is the main function. To find out the Z-score, this one is more than sufficient, but here, this still I used it. Let me tell you why. What happens, we says, if this is the mean, and here up to the values of 3 and -3, any value which are far apart from 3 standard deviation, here or here, or below -3 standard deviation, they are outliers. So the point is, what will happen, suppose, if I'm giving this formula Z-score, find out the Z-score of entire data frame, I would be getting all values which are coming in negative. So it will be calculating the Z-score of entire data frame. So some of the values are lying here. Some of the values that will be calculated below mean, so which are coming into the negative. And some of the values are coming here in positive. So what will happen when a lot of value which will started coming into the negative, which are below the mean, they will start creating a problem. So what I did, I had used just first to calculate the Z-score and then use numpy.absolute function. With the help of absolute function, all the values will be coming into the positive. And when I'm having entire values as a positive, it will be easy for me to work with positive values. So that I'm giving it here. Okay. So here now, np.absolute, find out the entire Z-score of the given data frame and find out the np.absolute. np.absolute means give all the values in positive. Now here in Z, here it is going to show you all the values in positive. So positive means here it is going to show all the values in positive. So this data is the positive data. So this one is what? This one is a Z-score. Suppose here, Z-score calculated for data frame is 0.20, 0.65, 0.51. Okay, different values are coming here. But all these formats are coming here in NumPy array. So what I'll do here, right now, when I'm checking out these values, I'm not able to understand that where are these values going on. So now what I'll do, I need to find out that show me those values only which are greater than 3. So means any Z-score value which are here, greater than 3 values only. Just show me those values. Now, because there's no concept coming for -3? The reason is there. I had just used np.absolute function. So after it, all the values will be moving towards the positive. So here the threshold value is 3. So any value which are having z-score value greater than 3, they are outliers. So these are outliers. I want to find out all those values which are greater than 3. Done. So once I'm able to find out, then I'll be detecting that these values are greater than 3 and these are all outliers. So then I used here one thing. That one is z value, the threshold value. I'm saying the threshold value is 3. And all the z-score value which are greater than 3. So it means all the values which are greater than 3. So 3 is there. Now this is the mean value. 3 is here. So all the values which are here, now here, greater than 3. That I need to see it. So when I applied it here, the threshold value is 3. Find out in numpy.where z is greater than 3. So here it starts showing me with np.where will start showing me that which are the rows and column where the z-score values are greater than 3. So here it is showing you that these are the rows and these are correspondingly columns where the values are what? Greater than 3. Okay, so greater than 3. So rows, columns which are greater than 3. Now how I can understand it? So what I can do, like I told you, these are basically rows and these are columns. How can I see it here? See, so if I want to check it out, what are the values? What are the z-score values? So I can take this particular z-score row and this particular column here. So here I can write z-score row and column I can give it. 53th row, 0th column. Row and column I need to give. In 53 row, 0th column. Okay. th row, 0th column, I can just find out that these are what? These are outliers. Just wait. Here in this way. So if I'm saying here row and column, you can find it out. So directly you can just check it out in this way. This and this. So if I'm mentioning here that in C, just 53th row, 0th column, what is the value coming here? So here it is saying 3.9. 3.9 is, it is saying 3.9 is the z-score value, which is greater than 3. Even the same if I'm writing in this way, like 53th row and 0th column, still it is working. Actually, this one is an older version. This one is a newer version you can work with. Suppose here you want to check it out, this value. Suppose here, what is the z-score value at 53th row and 6th column? So here you can give it in this way also, 53th row, 6th column. So if you write it, you will be getting the value which is up. Okay. Suppose here 88 is there and 2 is there. So here's Z. Suppose here 88 and 2. So if you write it, so you'll be getting the value which you are receiving, so that would be greater than 3. So it means that value is greater than 3. It means outlier is present here. Suppose here you can say, see, suppose this is 1457th row and the last column you can take it. So z-score row and column you can give it such as 11457 and the 2th column. So here you will be getting the last value as a for z-score which is greater than 4. So what I do here, I'm using the same, just like you can see here. Wait. Like various rows and column I took it. Like either this way also earlier I was using, but this is okay. This is okay. This is okay. Means here with newer version, no, this will work. This will work like 53th row, 0th column, 3.9 is the z-score value. 178 row, 9th column, 3.24 is the z-score value. Or 1457 row, 2th column, 3.07 is the z-score value. Here also z-score, here also. Here. This is okay. This is okay. So the point is here now. Here it shows that all these values, basically these values which I'm looking here, these shows that they are having all the values greater than 3. Suppose this is the main value and this is the threshold value 3. So here, these values are lying here which are greater than 3. Like these row and these column, they are having all the data which is greater than 3. So they are all outliers. So it means these are all outliers. These are all abnormal data. These are all abnormal data. Got the point? So in this way, we are detecting it. Done. Now, what you can do, here just I just mentioned here, like you know, in box plot, there's one of the figure here in box plot here. If this is a box plot, this one. So, you know, this value is basically IQR. If this is a Q1, Q1 means 25th percentile. And this one is Q3, 75th percentile. So IQR is equal to Q3 minus Q1. So here, we had find it out 25th percentile, 75th percentile, Q1 and Q3 is mentioned here. And if I want to find out the IQR, that is Q3 minus Q1. So here I'm finding it out, the IQR value, Q3 minus Q1. And here the entire interquartile values are coming here. Here IQR is coming, this one is IQR coming. Okay, this I'm just showing you how to calculate it. Okay, now you come here, just I want to remove the outliers which are abnormal data. How to remove it? How to remove it? So basically to remove it now, you need to apply, see, just wait. See, you came to know that the values which are lying here, this side, this or this side. Though I had taken a numpy dot absolute, I just put all the values into the positive data. But the point is, I will say these are abnormal data or outliers, you can say. I need, student, this value. This value means here, I need normal values. I need normal data. I need only this data. That's all. This one is a clean data. I will say it as the clean data. I need only this data. How can I get this data? This data could be get when I cut this normal values. I cut this abnormal data or outliers from the data set. How it is possible? You came to know that all the values which are here, they are greater than 3. And all the values, these are normal. So I need these normal values only. I do not need this one. So normal values are less than 3. Normal values are whose z-score is less than 3. So I will be picking only less than 3 values into the newer data set. So I'm writing here in HF, find out all the z-score value which is less than 3. Which is less than 3. Check it out in all rows as well as column. Okay? And check it out everywhere. In all columns and across all rows. Just check it out whether the z-score value is less than 3. If you are finding it out, the values which are less than 3, they are normal data. Shift them into the HF new. So in HF new, you will be getting the values. In HF new, you will be getting the values. Which values? Which are less than 3. So now if you check it out, HF new shape. HF new shape. This one is 1,372 rows with 11 columns. And if you check out HF dot shape, this one is a old data. HF, it is having 1,460 rows and 11 columns. And in HF new, 1,372 rows, which is a new data. So inside the old data, nearby 100 rows are cut. So basically this old data is a combination of normal plus outlier data. Which one? This one, 1,460 rows. But this data, newer data, HF new data, this one is only having the normal data, clean data with 1,372 rows. So nearby, 100 are less nearby. So these are left. So I will say HF new shape is basically clean data. This one is the clean data. So this HF, this line number 43 HF belongs to this data particularly. And if you come down, you can see HF new, this one. This is having only cut values. So this one is normal data only. It is having normal data only, which has removed nearby 100 plus rows, which are having z-score value about 3. So it means outlier data has been removed. And this HF new file is the clean file. Clean file, clean file. Okay. So in this way, we clean the data. In this way, we clean the data. Means here, we can remove the outliers with all these techniques. I'm just scrolling it. So in this way, you can take any of the files, any file from GitHub, and you can find out the outliers. Okay. So in this way, you can remove the outliers. So entire process we need it. Fine. Now, let's say EDA. Let's see what is the EDA. Wait. Basically, EDA is one of the statistics process, basically. In statistics, EDA, exploratory data analysis, is an approach to analyze data sets to summarize their main characteristics by using visual methods. A statistical model can be used or not, but primarily, EDA is for seeing what the data can tell us beyond the formal modeling or hypothesis testing. You can say the exploratory data analysis, EDA, is statistician way of storytelling where you explore data, finding patterns, and tells insights of the data. Exploratory data analysis, EDA, is a phenomena under data analysis used for gaining a better understanding of data, aspects like their main features of the data, variables and relationships that holds between them, identifying which variables are important for our problem. So when we do the EDA process here, we need to take certain steps. So here we need to use the multiple library, such as Pandas, Matplotlib, Seaborn library. So here what we can do, we can read the data, we can make the hypothesis, we can look the variable identification, we can find out the input data or output data. We can just do the univariate analysis where we can make certain graphs such as histogram, bar chart. We can do the bivariate analysis where we can take two variables data such as scatter plot, pair plot. We can detect the outliers. Outliers are also detecting as the anomaly. Anomaly detection is also the outliers. Handling, removing null values or the missing data, and handle the categorical data also. That also we can do that. So now let's take out one of the file and let's do certain EDA. So right now I'm taking one of the file, which is a wine quality red.csv. I had loaded a lot of files here to do the EDA. You can find out the wine quality red.csv inside the DS data as well as dataset1, you can find it out. Inside wine quality red.csv, you can find out a lot of variables are there. Inside the variable, you can find out some of the variables just like fixed acidity, volatile acidity, citric acid, residual sugar chloride, 2p sulfur dioxide, sulfate, alcohol, and the quality of the wine is there. So what I can do, I can start making the EDA, exploratory data analysis of such data to find out the insights of the data. So here I can just say df.shape. Shape means here it is just saying what is the shape of the data. 1599 rows and 12 columns are there. What are the data types? Data types are almost float and the quality is integer. These are the column names here. These are the information, whether null values are there or not. So inside this particular data set, there's no null values here. Let's talk about the summary statistics. Inside the summary statistics here, it will be giving the entire details of the statistics around each column, integral column. So here it will be giving the count, the total number of rows, that is 1599 rows. The mean is 8.3 is the mean for fixed acidity, 0.52 is the volatile acidity mean, 15.8 is the mean of 3 sulfur dioxide, 46.4 is the total sulfur dioxide mean, and others. Standard deviation. Standard deviation is 1.74, 1.17, or 32.8, 10.46. These are the standard deviation, free sulfur dioxide and total sulfur dioxide. Minimum. Minimum. So here it is saying The minimum value in free sulfur dioxide is 1. The minimum value in total sulfur dioxide is 6. Okay. In alcohol, 8.4 is the minimum value. Maximum value is 15.9 in fixed acidity, 1.5 in volatile acidity, 72 in free sulfur dioxide. In total sulfur dioxide, 289, and rest are there. Now, if we check it out, the percentile. So here it say 25th percentile value in fixed acidity is 7. 25th percentile in citric acid is 0.09. 7 is the 25th percentile in free sulfur dioxide, 22 in total sulfur dioxide as a 25th percentile. These are the 50th percentile as a median value. And these are the 75th percentile values in different columns are there. Such like I say 21 is the 75th percentile value in free sulfur dioxide, 62 in total sulfur dioxide and other. The point is there, it gives the entire statistical summary of entire file. Now, here, wait. Now here, we can find out that where the mean is greater than median. So here you can see, in few column, mean is greater than median, such as mean and median. See, 8.3 is the mean, 7.9 is the median. So where the mean value is greater than median, so that data, it means Q data. Suppose here, you can take any of them. Suppose here a small difference is there, mean is greater than median, little bit only. Mean is greater than median, so some skewness is there. The point is there, some skewness is there. Okay, what the point here? So wherever the mean is greater than, so it means in all those columns, some skewness is there. Okay. Now we can check it out, the spread of the data also. Spread. With the spread, you can just check it out, the difference between the 75th percentile and the maximum value. In 75th percentile, see the difference. 9 and 50, abrupt changes there. So here, spreading of the data are also possible. Spread of the data are possible. See here, 2 and 15, the difference is too high. So spread of the data are too high. Spread means here, the data are spreading. This is okay. See here, 62 and 289. So the spread of the data here also, so you can say the spread of the data are very high. Certain if the spread are not, suppose that this is okay. So here there is no data spreading. It is okay. This is okay. So there is no data spreading. It is okay. But here the spread of the data are very high. Whenever data spreads are very high, what does it mean? Whenever spread of the data are very high, such like here. Such like in residual sugar, in free sulfur dioxide, total sulfur dioxide, it means outliers are present. Such like these cases, it means outliers are present. If the spreads are very high, outliers are there. So outliers are there. Okay, and some skewness is present. Okay, so these are the observations we are making it here. So basically, when we are doing the summary statistics, we have not described, we need to make the key observation. So into the key observation, we need to write it, such as the mean is more than median in almost all columns. There's a large difference in 75th percentile in maximum residual sugar, free sulfur dioxide, and total sulfur dioxide common columns. By these two observations, we can suggest that there are extreme outliers present in columns, these particular columns. So it means outliers are there, so you can remove the outlier because cleaning of the data are also required. Now let's go ahead into the EDA process here. Exploring the data variables here, such as there is one of the column here, quality. So you can see here quality, see here, say this one. If you see this quality, this one variable, there are the values 5 and 6. So there are certain more values. Just wait. See this one. There are the more values basically. You can just take it out 5, 6, 7, 8, 3. So it means the point is the quality of the wine is 3, 4, 5, 6, 7, 8. These are the values. So I'll say these are the low quality. These are the medium quality wine. This one is a high quality wine. Almost 8. Okay, you can see. So now let me check it out with the value count function. Value count functions will be conveying that inside the pandas, there's a value count function which will be giving that in 599 rows, how many rows are dedicated to 3, how many rows are dedicated to 4, how many rows are dedicated to 5, and goes on. So 681 rows are dedicated to 5, 638 are dedicated to 6 quality, then 7, 8. So you can see here, 3 is a low quality wine, 8 is a high quality, low quality. So for 3, there is a low quality wine, and for 18 number of rows. It means 10 rows are dedicated to 3 and 18 rows are dedicated to 8. So low quality wine and high quality wines are there. So these observations are there. Now let's go ahead with the data visualization. Just wait. Just wait. Okay. Now see data visualization, we can do it here. If I want to find out, is there any data as a null data? So here it is saying there is no missing data, because what happens now, directly also I can find it out with df.isNull.sum. If I'm writing here df.isNull.sum, with this also I can find out the total number of null value. But here right now, I'm just looking the visualization method. So if any null values are there, so I will be start looking this yellow lines. It means in this particular column, these null values are there. But right now, there's no null value. This box is clean. Now, if I want to find out the correlation, so I will simply write here df.core. So here it is just calculating entire correlations. Okay. So df.core, and inside df.core variable, I'm storing the entire correlation. Now I'm just taking this df.core inside the heat map. So df.core. So here it is just showing me the color which is appearing this side, lighter side. They are highly correlated. And the color which is appearing this side, downer side, darker side, they are negatively correlated. Here positive, here negative. So if you start looking these colors, suppose here, see this one, lighter side. Free sulfur dioxide and total sulfur dioxide, they are highly correlated to each other. Alcohol and qualities are highly correlated with each other. Volatile acidity and citric acid, you can see it here, white and black. So these are negatively correlated with each other, negatively correlated with each other. These are neutral. All they are neutral. So the point is here, these in this way we can find out whether the values are highly correlated or not. Now here you can just see quality and see which variables are giving high inputs to the quality of a wine here. So if you check it out the color, so here it says that alcohol is giving high input to maintain the quality. Then sulfates and like citric acid, they are also making some of the neutral impact onto the quality. But which variable is carrying the negative quality, negative attraction of the quality? So here it is the negative side, this one black. So here volatile acidity shows the negative impact. Volatile acidity shows the negative impact basically. Okay. So because this is a blackish in color, so it says volatile acidity is giving negative impact on the quality, Okay, the same I can just check it out with a heat map with different colors also. So here you can just write plt.figure just to increase the figure size inside the matplotlib.figure. Figure size you can give the pixels of the width, height and width. So you can give it, if you give it 10,10, it will be improved. You can do that also. Bigger size. Okay, so this one is, I'm just passing out the TF call, color map is equal to blue, annotation is equal to true. So if it annotation, entire all calculated values, correlated values are here, appearing in these boxes here. Okay, now, so from here now, see from here, just see. Here I just taken the another color. I just increase this figure size here in plt.figure 10,6. So it is larger size boxes of for larger size. I'm just giving a DF code inside the heat map, color map, and these are the codes. You can take out this code from if you're on Google, you can just write matplotlib colors. So that will open the matplotlib colors gallery. From there you can find out the code colors, coding of the colors. You can find it out there. Okay, annotation is equal to true. You can see all these data. From here also, you can just check it out. The lighter shades here, be careful here. The lighter shades which are coming here, they are positive. Here, these are negative. If you see, suppose I say these one, just wait. These one, you can see it out. These one, oh, it colors are different here. Say here, these are volatile acid and citric, these are negative. Three sulfur dioxide and total sulfur dioxide are positive in correlation. They are positive in correlation. These are negative. These are negative. And here these are positive. Sulfates and alcohol, these are positive, and these are also positive. So if you check it out here, which one is very negative behavior? So see this color. Volatile acidity. Volatile acidity is giving very negative input into the quality. I can drop it. Even alcohol is working good, sulfates are working good, rest are neutral. Okay, so all the observation, I just written it, means related above whatever I have observed, that which are highly correlated, which are what variables are negatively correlated, what variables are very highly correlated. So that observations needs to write it here. So during the EDA process, one needs to write the entire observations, what you observed regarding to the EDA. Okay, now we need to check it out the outliers. So I'm just checking it out the outlier. I'm just taking all the columns here, trying to find out the outlier. So yeah, inside this, I'm just doing the univariate analysis now. Univariate means single column analysis, single column plotting. I'm doing it here. So here I'm taking a fixed acidity column. So here it is saying outliers are there. Citric also, citric acid outliers are there. This one is the univariate analysis, one column graph here I'm just making. Free sulfur dioxide, here it is saying, yeah, outliers are there. Outliers are there. Total sulfur dioxide, yes, outliers are there. So basically inside this file, outliers are present. Shape is 1599 rows. So here I can just see, here I'm just looking one by one, univariate analysis I'm making. But if I want to see everything at a one, so I can just see in this way also. At a glance here, I can see it here. So here it is showing your outliers are present. Outliers, 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 outliers. So outliers are present here. df dot plot, box plot, subplot is equal to true. Layout parameter I can settle down with 2 rows, 6 columns. So 2 rows, 6 columns, row number 1, row number 2. So here, like here, if I'm saying layout is equal to 2 rows, 6 columns, here it means 1 row, 2 row. First column, second column, third column, fourth, fifth, sixth. Then again 1, 2, 3, 4, 5, 6. So total 12 columns at the moment we can see it. So here 12 columns of entire file are showing 1, 2, 3, 4, 5, 6 and 6 here. So 12 column we can see it. And here it is showing, yeah, outliers are present inside this particular CSV file. Now I want to check out the distribution, because we had learned about lot inside the file, Seaborn file. So density distribution, I'm looking at here. Here it is showing it is a normal distribution file. In citric acid distribution plot here, I'm making to check it out the distribution. Here it is saying little bit skewness is there, small. I can just move it, write it into the subplot also. So I can move ahead with more distribution plots and histogram. I can draw it. Means more exploration one needs to do it here. And here, I just given entire subplot here so that I can see the entire data. Here I'm making a scatter plot. Scatter plot is also bivariate analysis. 2 variable data here I'm taking. So just wait. Here, whenever I'm doing the scatter plot, we can see is there a relationship here? So here it is just a neutral relationship between the pH and the quality. Okay. Here pair plot we can take it. Like here, 2 pairs it is making, like here it is saying positive correlation, it is negative correlation. Like here it is normal distribution. This is also normal distribution here. Here it is showing the positive correlation. So the point is here it is showing you that that if you check it out, the name of the file, these are the below, there are the names provided for the particular column that shows that what are the distribution for individual column here. Like this one is a normal distribution. This one is a little bit skewed distribution is there. Okay, so in this way it starts showing you the data in pair plot also. Okay. Now here I want to check it out the missing value. So basically during the ADA, we need to clean the data. So here we are removing the missing value. If there is a missing value, we need to remove it. We can drop the negatively. If there is a negatively correlated column, that also we can drop it. We can remove the outliers. So this entire process is known as EDA. We call it a data cleansing also. During the EDA, we need to do the lot of data cleansing here. So here plt.scatter, here I can just give it such as plt.scatter. DF volatile acidity, DF quality is there. So here it is showing scatter plot. This is a neutral relationship. Okay, one more thing here. In volatile acidity, now, if I want to drop that, actually, I want to drop that. So here, I'm just dropping the volatile acidity, this one. If I want to drop it, simply I will write it df.drop volatile acidity along with a column in the same data frame. And then if I see it here, there is no volatile acidity column. I dropped it. No volatile acidity column. Now, if I'm checking out the shape, earlier it is 15, 99 rows and 12 column. Now it is 11 column. Now, if I want to remove the outlier because we are doing the we are cleaning the data. So here during the cleaning the data, the same process here, I'm going to do it. I'm going to call the z-score from scipy.stat, finding out the z-score value. And then here threshold value, I'm just taking it out greater than 3. So here it is saying, yeah, there's a lot of outliers are there. Okay, I said, if I want to check it out, here it is showing at different values here. Outliers are present. Here now I need the clean data. So simply I'm writing here, just give me all the data values which are normal in all the rows and all the columns here. And this one is the newer data. So this data which I'm getting the normal data. Normal data here I'm getting. Normal data. So older shape is basically 1599 rows and the newer shape is 1458 rows. The point is 141 rows are deleted basically. 141 rows are deleted. So the data cleansing is done. So you can do the EDA on your own. You can take any of the files, Titanic, any file, you can just take it. It is provided here from the GitHub and you can do yourself. This is one case. Now let's see another file here, EDA brain size also. You can see how I can do the EDA if the null values are there. See here, brain size.csv I'm loading. You can just find it out, entire this file, and you have to write this file on your own. I never give any file because you need to write the things on your own. You will be watching out the video multiple times so that you can remember the code automatically. And once you are watching out the video little bit 1 or 2 times, so you will start writing the code on your own and it will be very good for you to remember the code on your own. Okay, so just watch out the video, write the file on your own. Here I'm just loading the brain size 1.csv. You can find it out inside the DS data. Head, I'm just doing the data EDA. Okay, I can call this EDA process as the data wrangling also. I'm just wrangling the data up and down. So df.head, df.head 10, df.tail, okay, df.tail 10 or 5, you can do that. So all the data, I'm just looking at here, sample, df.sample 4 in this family. Shape is there, 40 rows, 8 column. The data types it is showing, integer, float, or integer information it is giving. Here it is saying, yeah, some of the rows are missing value. Some of the data are missing value. So here I'm just checking it out, df.isNull. There is in isNull data. So here it is saying, yeah, some of the values are null. Let's just like true. So here the values are true. So it means these values are null. They are gone away. They are not there. Now, if I want to check it out, df.isNull.sum. So here, df.isNull.sum here, some 1 row, 2 row, 5 rows, 2 row. So here it is showing these data are missing data. NaN values are there, missing data are there. Okay, df.isNull is there. So here it is showing the SNS.heatmap. Is there any data missing? Yeah. In VIQ, these values are missing. In PIQ, 3 values are missing. In weight, 2 values are missing. In height, 1 value is missing. In FSIQ, 1 values are missing. So these are the missing data. What are the column names? These are the column name description methods. So one has to check it out, the description, write your self-observation, for the skewness, outlier present, just out there checking out the values. Now, there is one of the column here, gender column. I want to check it out, how many rows related with the gender, male or female. So here it is cbond.count plot function. So here it is going to give you like nearby 20 females and 20 males are there because 40 rows are there. I can see the univariate analysis here just by checking out the distribution. So here it is saying it is almost normal distribution here also. It is normal distribution into weight. So number of columns you can take, start plotting them. Box plot, there is nothing outliers inside the weight, no outliers in height. FSIQ does not have any outliers. In VIQ also there is no outlier. So I'm doing the univariate analysis. This is also clean. Null data are there. Yeah. Remember, whenever I'm having a null data, how can I handle that? If I'm having one of the values, suppose here I say, see, if you're having, suppose PIQ column, it has having NaN values. It is having NaN values. So if I want to say, there is one way, either I write here df.drop. Students, remember, suppose you are having 100 rows. Inside the 100 rows, if you are having 2, 3, or 4 rows which are having missing data, you can drop it. But if you are having 10 rows, 15 rows, 20 rows, you can never drop any of the rows. Instead, you can find out the mean, median, and you can replace the NaN value with a mean or median. So I will not prefer it. What I'll do, suppose here I'm just taking PIQ column. PIQ column is having 5 rows. So out of 40, if I'm deleting 5, so I'm losing the data. I should not do that. So what I do, I would be replacing this PIQ column with mean value PIQ. So here I'm using the pandas replace method. So inside the pandas, I'm finding out the PIQ dot replace, and inside it, I'm saying just replace the NaN values by finding it out PIQ column mean value into the same data frame. So here, once the PIQ column mean value has been found out, suppose 9.5. So 9.5 is going to be written here in NaN values. So just find out the mean value of PIQ column, replace here. And put out NaN. Okay. So replace method, we can use it. So it is suggestible when large values are there, do not drop it. Do find out mean or median and drop it. Now, if you are checking it out after this mean value in PIQ column, this column. So again, I'm checking out if any null values are there. So PIQ is 0 because I had replaced it. Now, if you're looking here, suppose there are very few values, 1 or 2 rows inside this column. So I can drop it. These are very few values. Simply, I will write here df.drop NA along with rows into the same data frame. So it will drop all the rows. And if again, I'm checking it out, df.isNull.sum. So here it is going to show you 0 values. So all the missing data has been cleaned, and now it is showing you clean data. df.core, it is here, it is showing to you. Internally, it will be calculating the correlation value, finding it out to you. So here it is saying height and weight are highly correlated, or FSIQ and VIQ are highly correlated. In this way, it is showing to you. Here I can just see the df.core value with annotation is equal to 2 into the heat map as well. So this is a way of doing the basic EDA process. I can do it. Exploratory data analysis, or even you can call it a data wrangling, and just wrangle out the data. Actually, I'm looking out the entire insights of the data. Okay, so this is overall for today, entire EDA process. The exact condition to drop the column is, to drop the rows is, it means, see, we should not drop the larger number of rows. I'm giving an example. Suppose 100 rows are there total, and out in 100 rows, it 1, 2, 3, 4, 5, that's all. This many rows are there which are having missing data, we can drop. But if they are greater than 5 or like it is 10, it is 15, it is 20, we should never drop the rows. Even you can find out the mean or median, replace it. We should not lose the data in this case. Okay, so in this way we can drop the rows. That's all for today. Thank you. From tomorrow, I'm going to start with the ML, machine learning.